In this video, I want to kind of provide some tips and tricks for the activities and labs that are due this week. All right, so in chapter 2 and 3, it's a bit weird. So you have two files, right? You have the data all in one file in the Excel file, and then you have the Word file that has all the prompts that go with the data set. Normally when we do this in class, I give the students the prompts on paper and then just the data to work through in class. And so I'm providing it to you in this format so you can decide, do you want to do everything, like copy everything from Excel over into Word, or do you want to take everything from Word and put it into Excel? I'm fine with either format. Just make sure to submit one of them, right? So in activity one, fairly standard. So you have, just be careful though, there's two different treatments, right? So it says make a box plot comparing the tumor increase under the two conditions and compute the mean and standard deviation. So there's one treatment, right? There's buffer and then there's nanoparticles. Separate them, make two different box plots. Or if you are very clever, you could do something like, oh, I'm going to put the nanoparticle data right next to this. So you're going to like move the data set. Oh my God, why can't I do it right now? Select the boundary, move it up here. And then you could, if you wanted to, put both on one and then just provide a legend indicating, which one's which, right? And there was some discussion on how to modify the legend in last week's posts on Canvas. So if you're confused on how to modify the legend, look at week 1 posts. Okay, so that's an optional if you want to do it all in two separate charts. That's perfectly fine too. Okay, there we go. In activity 2, right, descriptive statistics 5-number summary, single chart has side-by-side box plots. Okay, so this is kind of where you have to do, highlight them both, insert. When I say side-by-side box plot, I mean like one chart with two boxes in them. Okay. And then this one, part C, it says, IQR rule. So at least based on the first chart that you make, right? You see that there's Excel is saying this is an outlier. I'm going to remove it. There's actually more than one outlier using the IQR or the 1.5 IQR method. So very, very important. When you're altering the data set, always work from a copy of the data set. So once you get to part C and you need to, remove outliers, I would say, okay, first thing, make a copy of the data set, figure out where the outliers are, and then take them out. Okay, you have to do like the 1.5 IQR rule for the group and a separate one for the individual. Okay. Number 3, activity 2.3. So this one, about breastfeeding mothers, and then here it does say 4-step process. So this is the state, plan, solve, conclude. Okay, and so here very little direction, a lot of context, right? But so the ultimate question that you want to answer is this one. I'll bold it here, right? So that's pretty much your state step. So congratulations, 1 of 4 parts is done. But in the videos, there was a very, very clear instruction on, what should be included in state, plan, solve, and conclude. The one thing that we tend to get hung up on is assumptions. And later in the course, this will be very, very explicit for us. But for now, I just want you to say, I want you to think about this question. What chart is being made and what is needed to make that chart? Okay. So in chapter 2, you learned one specific type of chart. Hint, hint, wink, wink, nudge, nudge. Make that chart. Okay, but what do you need in order to be able to make that chart? What sort of data, what type of data do you need? Okay, so if you address that in the assumption, you're going to be golden. Okay. Other questions, feel free to reach out. I will be checking Canvas much more frequently this week for discussion posts. Let's see, chapter number 4 in activity 3, 3.1. So here, I mentioned in the video assignment that, by default, we put, when we make a scatter plot, the value on the left is put along the horizontal axis, and typically that's our explanatory variable. So our explanatory variable data should always be on the left, and our response variable should be on the right. And so here I'm posing the question, is the data as presented explanatory response, or do you need to switch it? Okay, and so make that argument for why it is the way it is, and then make a scatter plot, and then describe the overall pattern. Striking deviations. I ask you questions. What is a striking deviation? It's a visual outlier. Okay, anything that seems far from the cloud of points. And here I'm not asking you to do the 1.5 IQR rule. Just say, does this seem weird? Does it seem different than the overall pattern? Okay, and the last exercise here is another 4-step method. So just this time, you're going to be having to make a scatter plot. Okay, so hopefully these activities in chapter 2 and 3 help you with the 4-step method. All right, next up we have chapter 4. Okay. Well, boy, this problem looks very similar to one that we just saw. Yeah, that's because it's the same context, right? We're just asking you to do different things now. So that diabetes and obesity context, right? Same idea. Okay, so make a scatter plot, this time including an LSR line, trend line. Do some calculations, and then I'm just going to caution you, always make sure that you're predicting within the range of the explanatory variable. If not, what do we write? Probably not possible. Let's see, interpretation. So this one, when I say interpret, it's generally like in the context of the problem. So what is X? What is Y? Interpret slope and intercept using the language of the context. So in this one, you should be talking about diabetes and obesity. Okay. And then coefficient of determination, I mentioned this in the video assignment, what the coefficient of determination means and how we interpret it. So now think about that as you are writing your answer to this part F. Exercise 2, there's a post on this. This one is to help you identify influential observations versus outliers. Outliers are just generally extreme values of a variable. Influential observations may or may not be outliers, but they are rather points that significantly alter the correlation. So we sort of need to do look at the original one, and then make a copy of the data, remove that point, and see what happens. If the correlation changes, then it's influential. Okay? If it doesn't, then it's not influential. So this exercise kind of leads you through that. Exercise 3 is super fun. It's a fair amount of work initially, but when you look at the scatter plots, it's actually kind of wild. So have fun with that one. This one I typically don't get many questions on. Exercise 4. Now this one is our first exposure to a a larger data set. Yes, the diabetes and obesity one is large, but it's large in the terms of number of observations. So here, you will have to do some filtering. So if you haven't worked with filters before, you can highlight the column headers, and then in the home section of the ribbon, go to the editing section, and then there's sort and filter, and select filter. Okay, and then that puts drop downs that you may have seen before. Okay, and this first one we're looking at age in years and height in inches between boys and girls, so we actually need to separate it based on sex. So if we sort it smallest to largest, it's going to put all the zeros, which is, let's see, if we hover, so that's not it. So girls are zeros and boys are 1. And then we'd look at, height and sex, let's see, age and height, age and height for all the girls. We'd have to make, one scatter plot for them, and then make a different scatter plot for age and height for boys. What I would recommend, okay, take this data set, once you have it sorted, make a copy of it off to the right and work from that copy. Again, every time you alter, I get nervous about altering data sets. So work from a copy, and then that way the original is always there for you to go back to if something gets messed up. Okay? So make it, sort it, copy it over here, make a chart for boys, make a chart for girls. Okay? Part B is similar, but you're looking this time at different age ranges. So you're going to have to sort by age, smallest to largest, and then look at height among those different age groups. Okay? So then again, once it's sorted, make a copy, put it off to the side, work from that copy. All right? So this is a good professional skill, is knowing how to manage and work with data sets. So hopefully this exercise allows you to begin working on that skill. All right, so that's a little bit of an overview of the different activities for this week. If you have questions, post on the discussion board. If it's more urgent and I'm not seeing it, feel free to send me an email. And otherwise, have fun and let me know how I can help.